Hi everyone, thanks for coming. And I'm really happy to be following some of those presentations because especially Eileen's work and Irene's work both overlap with some of the concepts that we'll be going over here. So my talk is Disparities in Text-to-Image Model Concept Possession Across Languages. So what does that title mean? Well, text-to-image models, or T2I as I'll be calling them in this presentation, have grown more and more popular, but they have a lot of bias issues that are not necessarily obvious at the outset. So this whole work was motivated by basically just me playing around with DallE Mini, aka Craiyon, and prompting it in different languages to generate things. So what is a big dog to DallE Mini? Well, type it in English and it gives you pictures of Labradors and pictures of German Shepherds. Okay, makes sense. All right, well, let's try asking it the same thing, but in Spanish. So if I ask it for perro grande, well, same thing, it generates pictures of dogs. What about Indonesian, though? I'm not going to pretend I speak Indonesian, but we prompt it once again, generates pictures of big dogs in Indonesian. So then I'm like, okay, well, does DallE Mini know Japanese? Let's try big dog in Japanese. What the heck? And it turns out there are many such cases. The problem with these biases is that there are collisions that are unpredictable and offensive. And how do we find more of them? And how can we mitigate them? That's the motivation of this talk. So in order to handle this, we introduce a tool for finding and analyzing these unanticipated issues through the lens of multilingual conceptual coverage. So my apologies for putting just a giant plot up here, but it's because the technique is really not the core point of the story here. This is an abstract for this conference for the purposes of delivering the findings. The technical details will be explained more at ACL, and you can check out the paper. There will be a link at the end. But basically, the core points that I want to illustrate here is that we take a list of 200 tangible nouns that we want to test for, and maybe there's going to be a collision. So we can test for dog, airplane, moon. Oh, I have a very shaky hand. See, we feed all of those into an ensemble of commercial translator systems like Google Translate, and then align those and check them against the Wiktionary and Wikipedia knowledge graphs of translations of terms in the different languages to try to get some notion of correctness in their outputs. Then we prompt each of the models that we want to test on as basically a black box and look at the populations of images generated for each language. So the population of images generated for, give me a picture of an airplane in English, Spanish, Japanese, etc. And then we can compare them using automated features, which I'm not going to explain in detail here because, once again, I'm more interested in the qualitative part and the questions raised. So we test the Craiyon model, DallE Mini Omega. We test StableDiffusion 1.1 through 2. We test CogView 2, which is a Chinese language model developed academically. We test DallE 2, and we test AltDiffusion, which is an updated fork of StableDiffusion 2.0 that's trained to be multilingual. So this is the kind of stuff that you would see if I was giving the ACL talk. Basically, we can plot every single concept on a histogram for how well represented it is in each language. And this gives you at a glance how well each model knows the languages. So when there's rightward mass, more concepts are known. Leftward mass, fewer concepts are known in that language. And we see some high-level trends like models that are trained on English favor Latin language words much more than languages that don't use the Latin alphabet, such as Chinese, Japanese, and Hebrew. Conversely, the model trained on Chinese only really transfers to Japanese, and it's equally bad on basically all of the non-Sinitic script languages that we tested. Finally, AltDiffusion, which is the only one that's explicitly trained using a multilingual encoder, has far and away the best performance across the languages. But this actually comes at a cost to English performance and other subjective costs that I'll cover shortly. So this is basically showing that we can sample a given concept from those histograms, and we can confirm that when a concept is far to the right, such as rabbit in Spanish, it's well represented and it's close to what you'd expect. But if it's far to the left, it's totally wrong. So here's eye in Hebrew. Those aren't pictures of eyes. The model doesn't know Hebrew. But now we're going to get to really the core of what I wanted to share with you all, which is the differential biases that we find between languages. So these are three populations of three different languages where I asked DallE to give me a picture of a dog. Can anyone guess which one is Japanese? Pretty easy, right? The cultural default of what a dog is differs between these languages. And this bias is actually picked up in the model as it gets trained. But the thing is as we test for more and more concepts, they grow less and less funny, less and less innocuous. So if we ask a model for hair, the German default for hair, the Indonesian default for hair, and the Spanish default for hair actually really reflect stereotypes. And This could be considered problematic in my view. And it gets worse. We get to ethnic biases and gender biases for things like professions. So in DallE 2's case, the default for pictures of a human in English is actually Asian faces, interestingly, whereas the other models have a white bias for English. But we actually find a white bias for Indonesian on models on DallE 2 for some reason. And we also find that there is a male bias for doctors in English, but there is no male bias for doctors in Chinese and Indonesian. Sorry I'm giving just a super fast blast through all of these things, but at the end you can check our website and look at all the images we generated for all the languages and confirm for yourself. There's lots of crazy trends. And then finally we get to the most worrisome thing, which ties back to the initial talk, which is that racial biases and differential degrees of sexualization, depending on race, are actually picked up by these models. Going from German to Spanish to Japanese, we find increasing degrees of sexualization. So the question is, does the multilingual model address these problems? Turns out that it kind of does. So going back to our example at the beginning with the cultural default of what a dog is, that information is completely lost when we train a single multimodal encoder to take in the same input language. So while the disparity now between what a default dog is between the languages is removed, also the cultural distinctiveness that might be desirable is also lost. We find the same thing is the case for give me a picture of a woman. Now the differential degrees of sexualization between the languages is reduced. And additionally, the secondary characteristics such as, is it a sepia-toned photo or a black and white photo, which all of these things are unspecified. The prompt is literally just picture of a woman in these different languages. Those disparities are reduced, but diversity is also reduced. And the white default from English, and German, I actually don't have English on this slide, so just take my word for it, is then transferred to the other languages. So this raises some important questions, and that's really what I wanted to come here for and to get input on. So first of all is the grim reality of text-to-image training data. These social biases are coming from the data, and the data resources are huge. They're difficult to clean, they're difficult to diagnose. Multilingual mitigations, like training the model on a single multilingual encoder to map all the different languages into the same embeddings, will fix the differential degrees of bias, but they'll also remove all cultural distinctiveness, all diversity, and create the same defaults across all languages. So it's an important direction for future work to figure out interventions that can mitigate the biases, but maybe make things more appropriate language to language. And that leads me to really my core concern is, what are the desiderata in high quality, fair, and ethical multilingual text to images? So some cross-lingual differences obviously should be reduced. Obviously the unprompted sexualization, obviously the gender and ethnic biases should be reduced. But when we get to things like ethnic defaults, I'm not sure how comfortable I am condemning ethnic defaults in languages other than English that I don't speak. Maybe the ethnic default for Chinese should be an East Asian face. I don't know. And then when we get to the most innocuous defaults, like pictures of dogs, pictures of foods, apartments, and buildings, all of which are reflected in there, I'm even less sure of what the default should be and if it should be uniform across languages. Maybe a house in English versus a house in Swahili should look like houses in the different countries because that's what a user of those languages would expect. I really don't know. So this is where input, this is where input from the FAccT community would be greatly appreciated. So please reach out. Here's the link to our demo and paper. I'll be presenting the more technical details on this at ACL later this year. And this abstract was by me and, I did it again, me and my advisor, William, and with a lot of help from our newly minted Dr. Sharon Levy from our group. And yeah, check it out and share your opinions. Thank you.